So let's take a look at this and work out a quick example here. I want to find an approximate for the area of f of x equals x squared between 0 and 4. And specifically, I'm going to let n equals 20. So what I have is this curve of x squared from 0 to 4. So I know it's a parabola. It looks like this. And what I'm trying to do is figure out or calculate an approximation for this total area under the curve. And the way I'm going to do that is by breaking this up into 20 different boxes. So my delta x is going to be the length of this curve, or length of this interval right here, which is 4 minus 0, divided by the number of partitions we want, which is 20, which equals 1/5. So my area is going to be approximately equal to the sum k equals 1 to 20 of f of xk times delta x. And specifically, I said here, I want to use the left endpoint. So I need to figure out what it means to be at the left endpoint. Well, here, my starting point A equals 0 and B equals 4. When k is 1, I need to be over here at 0 because that's where my left endpoint is. When k is 2, I actually need to be at 1 because that's the left endpoint for my second box, and so forth. So the way I'm going to do that is I'm going to say that, hey, xk must be equal to my starting point A plus k minus 1 times delta x. So I'm starting at 0, and when k equals 1, this is 0. 1 minus 1 is 0. So my first value for f of x, my first value of x to put into the function, will be 0 in this case. When k is 2, I'll have 0 plus 1 delta x, because 2 minus 1 is 1. So I'm going to take A, add delta x to it. When I add delta x to it, that's that width right there. I'm going to be at that point right there, so I get the left endpoint. So from that, I can say, or this actually that implies, that what I have is the sum, k equals 1 to 20 of, see, I have k minus 1 times delta x, but delta x is 1/5. So up here, this is really going to be k minus 1 over 5. That's what my values of x are going to be. So for x, I have k minus 1 over 5. But the function is x squared, so this would be squared times delta x. Well, hang on, let me step back for just a second. This right here is representation of this right here, f of x sub k. Now I need to multiply it by delta x. But delta x was 1/5, so I'm going to simply multiply this by 1/5. So now I have this representation of my original definition or estimation of the area based on the left endpoint. Now this may look pretty daunting, but it's not. All we're going to do is a little bit of algebra on it, and I'm going to have this sum k equals 1 to 20. Just square this. I'll have k minus 1 squared over 5 squared is 25. 25 times 5, because I have a number 5 right there, is 125, which equals the sum. Actually, I'm going to pull that constant out. The 125, I can pull that constant out of the sum, make it a little bit easier. The sum, k equals 1 to 20. Square this thing. This is going to be k squared minus 2k plus 1. See, now I'm going to do is take this summation sign and I'm going to move it through. So I have 1 over 125 times the sum, k equals 1 to 20 of k squared minus 2 times the sum, k equals 1 to 20 of k, plus the sum, k equals 1 to 20 of 1. Well, see, I gave you formulas for these. So if you look back at your formula sheet, you see that this is 1 over 125 times, see, k squared is going to be n, which is 20, times 20 plus 1 times 2 times 20 plus 1 over 6. That is that piece right there. Minus 2 times k, well, the sum of the first integers is going to be n, which is 20, times 20 plus 1, because it's n plus 1, divided by 2. And then this last one, the sum k equals 1 to 20 of this constant 1 is simply 20 times 1, so that is plus 20. Now, obviously, there's some things I can do to simplify, like I can get rid of these 2's, make sure I don't lose the negative. I need to work this thing out, and this is actually going to be 21. That's this piece right here. This is 2 times 20, which is 40 plus 1, that's 41. So this top piece is actually 20. Let me write over here. 20 times 21 times 41 over 6. And I think you can see where this is going. Now it's just a matter of a little bit of arithmetic to put this thing together. And what you end up with when it's all said and done is 494 over 25, which is approximately equal to 19.76. So in terms of area, this is saying there's 19.76 square something. If I'm talking about area here, I don't know if my units is inches or yards or light years. I don't know what my units are, but whatever they are, it's going to be square something. So that's the area under the curve. If this was actually a velocity and time function, then this would be perhaps 19.76 miles traveled. It depends on the actual interpretation if you have a physical phenomenon you're modeling versus actually calculating simply the area under the curve. So now let's take a look at the exact same problem, only this time I want to use a right endpoint. It's the exact same scenario. So again, delta x is going to be 4 over 20, which is 1/5. X sub k is going to equal my starting point A plus k times delta x. This gives me to the right endpoint. So when k equals 1, I have a plus delta x, which is 0 plus delta x, which in this case would be 0 plus 1/5. So that would get me to the right endpoint of my very first partition, and so forth. I'd be on the right endpoint all the way through. So the area here is going to be approximated by k equals 1 to 20. This time, see, this is delta x is still 1/5, so this is k over 5. So I'll have k over 5 squared times 1/5. That's still my delta x. Well, that's going to be 1 over 125 times the sum of k squared. And we already used that formula for k squared once, so we know what that is. That's 1 over 125 times, actually I should put in here k equals 1 to 20. Okay, times, see, n is 20, so I'm going to have 20 times 20 plus 1 times 2 times 20 plus 1. Actually, yeah, I do need that. All over 6. Now, again, I can, this is just a little bit of arithmetic. And when I do all this arithmetic, I end up with 574 over 6, which is approximately equal to 22.96. Now, the left endpoint gave me 19.76. The right endpoint gave me 22.96. I'm feeling pretty confident that the actual value is going to be somewhere in between there. So what I'm going to do now is take a look at using the midpoint. Well, if I use the midpoint, there's two ways to go about it. I can either take the right endpoint and subtract delta x over 2, half of it, which would get me in the middle, or use the left endpoint and add delta x over 2, which will get me in the middle. Doesn't matter which. So if I say x sub k is equal to a plus k minus 1 delta x, this is the left endpoint, and I'm going to add to it delta x over 2, what I end up with is a plus k times delta x minus delta x plus delta x over 2. So this is going to be a plus k times delta x. Combine these, and I get a minus delta x over 2. Now notice right here, this piece is the right endpoint. If I use the right endpoint and subtracted delta x over 2, like this, that's where I'd start off with. So I start off with the left endpoint and got to this point anyway. So now I'm going to continue with it and finish up the algebra. And what I'm going to end up with, if I factor out the delta x, is I end up with, whoops, I need a first. A plus k minus a half times delta x. This will actually put me at the midpoint. So my area approximation is going to be the sum k equals 1 to 20 of k minus 1/2 over 5 squared. Remember, this delta x is 1/5, so this is k minus a half over 5 times delta x, which is again 1/5. And now it's going to be a matter of doing the exact same thing I've done before. So if I square this, I'll still have my 1 over 125 out front. And this, when I square the top, I'll have k squared minus 2 times k times a half, that's just minus k, plus the negative 1/2 squared, which is positive 1/4. Whoops. Sorry about that. I forgot my summation. I still need this summation. K equals 1 to 20. And again, if I break this up piece by piece and bring that summation through, I'm going to have 1 over 125 times k squared. We've done that a couple of times. That's going to be, in this case, 20 times 20 plus 1 times 2 times 20 plus 1 over 6 minus the sum of the k's. That's going to be 20 times 20 plus, whoops, that's a 20. 20 plus 1 divided by 2 plus the sum of 1/4. That's going to be 20 of them, so that's going to be 20 over 4. Again, this is nothing more but just a number. And when I work on that number and actually work it out, what I end up with is 533 over 25, which is approximately 21.32, which is in the middle of 22.96 and 19.76, just like I said it probably would be. So this midpoint, it would appear that this midpoint actually gives us maybe a little bit more realistic estimation, which kind of makes sense, because if I draw the midpoint real quick, well, actually we've already done it, but just very, very, very quickly, I'm only going to do it with a couple of points. If this is where my partition is here, and I use the midpoint, then this box is going to have a little over, a little under, and the tendency is that the overestimation and the underestimation will kind of cancel each other out, at least to some extent, on this particular function. So this midpoint would actually give me a better estimate when x is only 4.